Welcome to Trigonometry Part 4, which involves an introduction to trig identities. An identity is an equation whose left-hand side is identical to its right-hand side and is valid for all values of the variable. And we are abbreviating left-hand side and right-hand side as LHS and RHS for future reference. The symbol that is used to represent identical to is similar to an equal sign, but there's an extra line at the bottom, so it's 3 lines, and that means is identical to. So the process of proving identities involves an expression in which on both sides of the identity symbol we need to show that what we have written on one side is identical to what we have written on the other side. So two fundamental identities are tan theta equals sine theta over cos theta, something that we have touched on in our previous video, which also gives tan squared theta is identical to sine squared theta over cos squared theta. Another very important identity would be sine squared theta plus cos squared theta is identical to 1. And if we should make sine squared theta the subject of the formula, we would have sine squared theta is identical to 1 minus cos squared theta. Similarly, if we should make cos squared theta the subject of the formula, that will give us cos squared theta is identical to 1 minus sine squared theta. So these identities which we have looked at, our two main ones written in blue, and these that we have in purple have been derived from the two in blue, are very, very important when proving identities. And the point to note is that theta is a variable, and if any other symbol is used to represent the angle, whether it is alpha or x or anything else, the same rules would apply for the identities. Example 1. Prove that 1 plus cos theta by 1 minus cos theta is identical to sine squared theta. When proving identities, we just need to start off with one side of the identity and express it to give us something that is equivalent to the other side. So we can start with the left hand side or the right hand side, but I have chosen to start with the left hand side of the identity. So if we look at the left hand side, which is 1 plus cos theta by 1 minus cos theta, and we expand the brackets, so 1 multiplied by 1 will give us 1. When expanding brackets, each term in the first bracket must be multiplied by each term in the second bracket. So 1 multiplied by 1 gives us 1. 1 multiplied by minus cos theta will give us minus cos theta. Then the cos theta has been multiplied by these two, so cos theta by 1 is cos theta, and then cos theta by minus cos theta is equal to minus cos squared theta. So this expression on the right hand side is what we derive from expanding the brackets on the left hand side here. So just simplifying, on the right hand side we would have this part of it, this minus cos theta plus cos theta, that is similar to minus 1 plus 1, which is 0. Alright, so that term is removed and we will be left with 1 minus cos squared theta. Alright, so now that we have up to this point, we still need to look back at the identity, which is our first line in the example. We see that we want to express it to give us sine squared theta. So we are working towards obtaining sine squared theta. So here we have 1 minus cos squared theta, and I need to somehow get sine squared theta from this. But we have an identity which we looked at before, where we had sine squared theta plus cos squared theta is equal to 1. And from this, we have, looking at this one in purple, sine squared theta is identical to 1 minus cos squared theta. But the opposite also applies. So if I have 1 minus cos squared theta, I can replace that with sine squared theta. So in our proof, where we have 1 minus cos squared theta, using that identity, and again it can work both ways, then 1 minus cos squared theta can be written as sine squared theta. And once I have sine squared theta here, and this is what I need to get on the right hand side of the identity, then our proof is completed. Alright, so normally when we complete a proof, at the end of it we use a little box or a square, and also we can write QED, which is this Latin phrase that means the proof was completed. Example 2. Prove that 1 plus tan squared theta by 1 minus cos squared theta is identical to tan squared theta. So this proof is a little bit longer than the first one, but also simple. So I'm starting off with the left hand side of the identity. The first thing I'm going to do is to expand the brackets. So just as we did before, when expanding brackets, the first term in each bracket must be multiplied by both terms in the second bracket, and then the second term multiplying by both terms. So in other words, each term in the first bracket has to be multiplied by each term in the second bracket. So looking at this identity, I have 1 plus tan squared theta, but we looked at an identity before where we had tan squared theta is equal to sine squared theta over cos squared theta. So I'm just going to change this tan squared to sine squared over cos squared. After doing that, I'm going to expand brackets. 1 multiplied by 1 will give us 1. 1 multiplied by minus cos squared theta will give us minus cos squared theta. Now for our second term, sine squared theta over cos squared theta multiplied by 1 will be the same. And then sine squared theta over cos squared theta multiplied by minus cos squared theta. I just wrote them next to each other as it's being multiplied, and we'll simplify in the next line. So after we expanded brackets, we have this expression. Now where we have this last term, which was a product of these two, we can simplify it one step further, because we would have sine squared theta over cos squared theta multiply by cos squared theta, and then this term can cancel with this term and we'll be left with just sine squared theta. Alright, so from this working, that's how I got to this point. So this part of it was simplified to give this piece. Alright, so next we have to rearrange a few terms. Now the purpose of rearranging is to obtain the identity or the proof that of the identity that we would like. So if we look at what we have in our question, on the right hand side of the identity in the example, we have tan squared theta. So somehow we want to get tan squared theta by simplifying. And looking at our other identities, our fundamental identities, we have tan squared theta equals sine squared over cos squared. So once we get this part of it, this is equal to tan squared theta. So I'm rearranging because this part of it is what we want, but somehow I need to simplify the other terms to get that tan squared theta. Alright, so when I rearrange the terms, that means I am just putting this minus sine squared theta here, right? We would have 1 minus cos squared theta minus sine squared theta plus this term sine squared theta over cos squared theta. Now I'm going to factorize minus 1 from what is underlined in orange. The reason why I'm factorizing is because I want to be able to use the fundamental identities that we have. So looking back at these identities here, the second one, I have sine squared theta plus cos squared theta is identical to 1. So I want to somehow be able to incorporate that into our proof. Alright, so also a point to note is that addition is commutative. That means the order of the terms does not matter. So sine squared theta plus cos squared theta is the same as cos squared theta plus sine squared theta equal 1. Alright, so if I factorize minus 1 from what is underlined, I would have 1, then the minus sign. You can put in just minus in brackets, or you can add in a 1 here if you like. This is just optional to put in a 1. Okay, so factorizing that minus 1, we would have cos in brackets cos squared theta plus sine squared theta, and then this plus sine squared over cos squared. So in brackets, we have what we need for our identity. This one here, sine squared plus cos squared, is identical to 1. So I can now replace this bracket by 1 using that identity. Alright, so then here we would have 1 minus, this is being replaced by 1 based on our identity. And then we have our sine squared theta over cos squared theta here. And simplifying just this part of it, we have 1 minus 1, that is 0. So then we'll be left with our sine squared theta over cos squared theta. And we are getting very close to what we need to get. So on the right hand side, again, we are proving that this left hand side is equal to tan squared theta. Alright, so on the right hand side, I need tan squared theta, sorry. Alright, so once we get to this point where I have sine squared theta over cos squared theta, then I'm going to use the identity tan squared theta equals sine squared theta over cos squared theta, and same applies backwards as well. So then this is equal to tan squared theta, and that is what we want to get from our proof. So hence we have proven that identity, and this is the right hand side. So at the end of our proof, we can write the letters QED, or we can put our box to show that our proof is complete. Example 3. Prove that cos theta minus sine theta all squared is identical to 1 minus 2 sine theta cos theta. So for our proof, I'm starting off with the left hand side of the identity, which is cos theta minus sine theta all squared. So whenever we have an identity that you are not sure about how we are going to start it, you can relate it to something that is familiar to you. So for example, if in maths we have an expression such as x minus 1 squared, then this can be written as x minus 1 by x minus 1. So the same concept applies. So if I have cos theta minus sine theta all squared, then that is equal to cos theta minus sine theta by cos theta minus sine theta. Next, we are going to expand the brackets. So then I would have cos theta multiplied by cos theta, which will give us cos squared theta here. Then cos theta multiplied by minus sine theta will give us minus cos theta sine theta, or minus sine theta cos theta. Multiplication is commutative, so if I have sine theta cos theta, or cos first and then sine, it's the same thing. Alright, so I'm just writing the sine terms first. So again, cos theta by cos theta is cos squared theta. Cos theta by minus sine theta will just give us minus sine theta cos theta. This is the simplest form at this point, similar to if I have x multiplied by y, that is equal to just xy. So cos theta by minus sine theta is just minus sine theta cos theta. Okay, so now expanding, we would have minus sine theta by cos theta, which will give us minus sine theta cos theta again. And then our last term would be minus sine theta by minus sine theta, which will give us sine squared theta. So I'm just going to simplify similar terms. So I have minus sine theta cos theta minus sine theta cos theta. This is similar to if I have an expression such as minus x, then that will give us minus 2x. Similarly, minus sine theta minus cos theta is minus 2 sine theta cos theta. This cos squared remains, sine squared remains. Alright, so we are getting a bit closer to what we would like to prove. So just looking back at the example, on the right hand side, I have 1 minus 2 sine theta cos theta. We always need to look back at what we are trying to prove, and that will guide us as to what our next step should be. So looking at where we have reached so far, we are almost there, but we have this extra cos squared theta and sine squared theta, and we are also missing that one. So I'm going to rearrange. If I rearrange, putting the sine theta on this side here, we would have cos squared theta plus sine squared theta minus the 2 sine theta cos theta. And the reason for rearranging again is so that we can use the identities that we have met before, which is sine squared theta plus cos squared theta is identical to 1. So using that identity, then this written in this bracket here would be 1. And then I have this minus 2 sine theta cos theta. And looking back at the example at the top, we have on the right hand side 1 minus 2 sine theta cos theta. Here we have the same thing. So this is our right hand side and our proof is completed. Okay, example 4. Prove that 1 plus tan squared theta over 1 minus tan squared theta is identical to 1 over 2 cos squared theta minus 1. So again, I'm starting on the left hand side. Now on the left hand side we have tan theta, but on the right hand side I don't have any tan theta, I have cos instead, which means that to do our proof we need to change our tan squared theta or express our tan squared theta using the identity written here. Tan squared theta is identical to sine squared theta over cos squared theta. So if I use that identity, then 1 plus tan squared theta will give us this expression, and in our denominator 1 minus tan squared theta will give us this expression. So now we are going to simplify each one and then we'll put it together. So similarly, when we are simplifying fractions in maths, we would have, if I have 1 plus 2/5, then our denominator for 1 is also 1. Our LCM is 5. And then 1 into 5 is 5. 5 multiplied by 1 is 5. Then 5 into 5 is 1. 1 by 2 will give us 2, and so on. I'm just demonstrating again, just to simplify how we are adding fractions in maths with just numbers. It's the same concept that applies for our trigs. So then if I have, I'm just looking at the numerator for now. So 1 plus sine squared theta over cos squared theta. Alright, so looking at our two fractions, this 1 can be written as 1 over 1. Right, so our LCM here would be cos squared theta. And 1 into cos squared theta is cos squared theta. Cos squared theta by 1 will give us back cos squared theta. And then cos squared theta into cos squared theta is 1. 1 by the numerator will just be sine squared theta. And then, this is just an alternative to my solution written here. We can see that using our identity that we have learned before, which is sine squared theta plus cos squared theta, is identical to 1. If I use that identity, I would have 1 over cos squared theta. So that's our numerator so far. Now if I look at the denominator here, so I'm just taking this term and bringing it to the side. So our denominator then we have 1 minus sine squared theta over cos squared theta. So similar to what we did above, our LCM is cos squared theta, right? So 1 into cos squared theta is cos squared theta. Cos squared theta by 1 is the same, cos squared theta. And then I have cos squared into cos squared is 1. 1 by minus sine squared theta is minus sine squared theta. So after simplifying the numerator and the denominator, I'm just putting it back into my main proof. Alright, so in the numerator, it's similar to what I have on the right hand side here, except that I use the identity cos squared plus sine squared is equal to 1. Again, we can use our identities at any point. So this here is equal to 1. Our denominator is, again, what I got from here. I'm just going to input that there. Alright, and simplify further. So we have a fraction in the numerator, a fraction in the denominator. When we are dividing by fractions, we know that we multiply by the reciprocal of the fraction in the denominator. Or in loose terms, we can say that we flip the fraction and change the sign to multiply. Alright, so this fraction divided by this one in the denominator, we find the reciprocal and the sign is changed to multiply. So we can see that we have this expression where I have a cos squared theta here and a cos squared theta there in the numerator of the other fraction. So these two terms will cancel. Again, the only other change from what I did on the side was that substituting this as 1. Alright, so then that gives us 1 over cos squared theta minus sine squared theta. Alright, and we are getting a little bit closer to our proof on the right hand side. Alright, so then at this point we have in the denominator on the right hand side, in what we would like to prove, we only have terms with cos. We do not have any terms with sine. So that is how we would know that at this point where I have a sine squared term, that I want to replace that in terms of cos. So I'm going to use this identity. Sine squared theta is identical to 1 minus cos squared theta that we did before, and I'm replacing this sine squared theta by this 1 minus cos squared theta. Alright, so the sine squared is being replaced by this bracket. Alright, so from this point we are expanding brackets. So this minus 1 by this 1 will give us the minus 1. But then this minus is also being multiplied by minus cos squared theta. So then that gives us this plus sign here. Alright, so then from this point we have a cos squared theta in the denominator, cos squared theta minus 1 plus cos squared theta. Alright, this is similar to if I have x minus 1 plus x. That will be simplified to give x plus x, which is 2x minus 1. So that in the denominator can be simplified to 2 cos squared theta minus 1. And that is what we would like to get on the right hand side. 1 over 2 cos squared theta minus 1. So then, since this is equal to the right hand side, our proof is completed. So I hope that you all understand trig identities. So far, this is just an introduction. We have a few more concepts to learn in proving identities. Sometimes it may take students a little time to get the hang of it, because this is the first time that you would have been doing proofs of this nature. So if there are any uncertainties, you can feel free to contact me, or if it helps, you can look back at the video multiple times and see if you can follow what was done in proving the identity. So just to recap, that we did some basic identities, which is tan theta is identical to sine theta over cos theta, and that also gives tan squared theta is identical to sine squared over cos squared theta. Our second fundamental identity was sine squared theta plus cos squared theta is identical to 1, and from this we derive these other two. And we saw in our examples how these can be used to prove our identities. And the process of proving an identity is to show that one side of the identity can be expressed as the other side. and we are going to use these fundamental identities to show our proof. So feel free to contact me if you have any questions concerning how proving is done, or if you would like me to do over any particular example by explaining it in a different way or showing a different method. So that being done, we have another assignment consisting of 5 identities which you are required to prove. So feel free to attempt all of them, and for my class you can submit it to me on Edmodo. For other students, you can WhatsApp your solution to me at this number, and please include your name and school. Alright, so feel free to try them again, let me know how it goes, and we will continue in our next tutorial with further trig identities. Also, a solution video will be posted for assignment 4. Thank you for tuning in.